This video is for Geometry's assignment, Chapter 10, assignment number 5 notes. And the first part is an algebra concept that is helpful for working with circles a little bit later in the chapter. So we're going to learn this topic now so that it will make something that we do a little bit later easier for us. So the first thing that we're going to do is called completing the square. And you'd be given two terms of a quadratic trinomial, say x squared plus 10x plus something, and the task is to figure out what goes in this blank so that when I write this in factored form, that the two factors are exactly the same. And you just need to see an example to understand what I mean. So please follow along with the video and make sure that it makes sense, and I'll be available to answer questions on Thursday or Friday. So if you have x squared plus 10x plus blank, and I know that my goal is that the factored form has these two factors that need to be the same, then when I go to fill in these blanks, the trick is that these two have to be the same. And this is any other kind of diamond problem where normally you find these pieces and you know that these pieces have to add up to the 10x. And in this case, I don't know the top number, but I know that these two have to be the same. So if two values that add to 10x have to be the same values, then they must be 5x and 5x. And then, as the diamond always works, the 5x times the 5x is 25x squared. So you would put a 25 in this blank, and then you would carry on from there in factoring this polynomial. So those values are going to go right here as I factor this. And then we will get x parenthesis x plus 5 plus 5 parenthesis x plus 5. And then when I write that in factored form, I get x plus 5 times x plus 5, which is x plus 5 squared. And so the goal is, now that you can see the answer, it'll make more sense. The goal is to figure out what number you can put in this blank so that when you write this in factored form, these two factors come out to be the same, x plus 5 and x plus 5. Either both pluses or it could be both minuses depending on the problem. So I'm thinking that you might need to see another example, and then there'll be 3 for you to try on your own. So in this case, the only piece that I know of the diamond is that this has to be negative 12x. Now that doesn't seem like enough information to figure out the diamond, but the key is that these two have to be the same and they have to combine to negative 12x. So if they have to be the same, then it must be negative 6x and negative 6x. And then you multiply them to get the top, 36x squared. So then this must be 36, and you'll get then x squared minus 6x minus 6x plus 36. And those 6x's came from here. And then you just factor normally, x times x minus 6 times x minus 6, and we get x minus 6, or x minus 6 squared. So it kind of self-checks. If you get this value correct, when you write it in factored form, you end up getting this x minus 6 squared. So you're going to try these 3, pause the video and do them on your own, and then turn it back on to check. So in this case, 16 on the bottom, this will be 8x and 8x and 64x squared. So it will be a 64 that goes here. I don't need the 64x squared here because that x squared is already over there. So this will be x squared plus 8x plus 8x plus 64. Then x parenthesis x plus 8 plus 8 parenthesis x plus 8. And I get x plus 8 times x plus 8, or x plus 8 squared. All right, just so the video doesn't get too long, I'm not going to show this whole thing out, but this one would be 16, and your final answer should be x minus 4 squared, and this one should be 1, and your final answer should be x plus 1 squared. When you get to homework number 5 today, there isn't any new geometry on it, but it has some problems that require you to use your knowledge from assignment 10 number 4 and 10 number 3 and 10 number 4. So here's a couple examples that are similar to the ones on your homework. It says to find the value of x for each circle with a center of A. And so I have to remember that if I have an inscribed angle, that this angle here and this arc here have to be half of each other. So if, say, this arc was 50, then this angle would be 25. And I don't know either of those pieces, but because I know the 122, I can find this pink piece because this is a diameter, so this is a semicircle. So if you do 180 minus 122, you'll get what this length is. And 180 minus 122 is, I don't want to mess this up, grab your calculator so you're active also, and you should be able to do it without a calculator. You should get 58 for this pink arc, and then this angle x is going to be equal to half of 58, and so half of 58 is 26, no, that would be 52. Half of 50 is 25 and half of 8 is 4, so 29. And you don't have to do it in your head, but good practice to do that in your head. So x is 29. Actually, I didn't need that little degree here because there's a little degree in there. So to be more accurate, x should just be 29. So I knew that because this whole thing is a semicircle. A semicircle has 180 degrees in it. 180 degrees minus 122 gives me 58. And then these two, an inscribed angle is half of its intercepted arc. So they're kind of just angle puzzles, but using the things that we learned last class, in the class before. All right, so looking at this one, I'm trying to figure out how many degrees this arc is, and these are the pieces I'm given. So what's jumping out to me right now is that I can find this angle because all three of the angles in the triangle have to add up to 180. So I can take 180 and subtract 48 and 73 to get 59 degrees for this angle. And then I know that if I double this angle, I will get this arc, because this is on the circle and this is not. So then x will equal 2 times 59 degrees. So x will equal 118 degrees, or just 118. And this last one, same kind of concept, but this time there's more of an equation that you have to use to solve for x, and you're using the concept that if you double this angle, that you get this arc. So the equation that you would write is 2 times 3x minus 8 is equal to 140. And then you just solve that for x. You could distribute or you could divide by 2 here. Either way would be fine. 6x minus 16 equals 140. So 6x equals 156. And x equals 156 divided by 6, 26. As I'm looking at all of these problems, I have realized that I didn't cover anything with a central angle. So let's go back to number 5 and change the problem just a little bit so that there is also, say, a y right there. And if you had to find y, then this central angle y and this intercepted arc, the pink one, have to be equal. So if you know that this is 58, then the y has to be 58. So if we added a y to this problem at the central angle, then that's what it would equal. If you had to know, if you were asked how big this arc is, if there was a y on here, then you could double the 73-degree angle to get this y value. So 73 doubled would be 146. I guess we'll stop there. A few minutes left, so I'm going to turn this paper over and remind you how to find the equation, or how to graph the equation of a circle, because I noticed on some of your homework that some of you got these wrong, and I want to make sure that you understand it. So stick with me. Just to be sure that you know what the graph of, say, x minus 3 squared plus y plus 2 squared equal to 16. Let's say that we needed to graph this equation. So the center and the radius. I know that this format will give me a circle. If you weren't sure and it wasn't an example that I was working with you on, you could type this into Desmos just like this and you would get a great graph of that. So I would encourage you to do that as you're checking your homework. So the center of this circle will be at +3 and -2. These values always feel backwards from what is in here. So if this says x minus 3, then the center is at a +3. And if this says y plus 2, then the center is at a -2. And this value represents the radius squared. So if r squared is 16, then the radius is 4. So if you went to graph this circle, the center would be at +3, -2, and the radius would be 4. So I'm going to freehand a circle here. There's the radius trying to be 4 units, and the center 3, -2. All right, thanks for watching. The homework handout will be similar problems to these, and thanks. Hope that you're doing well.